Today's lesson is on circumscribed polygons. Let's start with the definition. A circumscribed polygon is one that has a circle inside itself and touches at all points. For example, you have the triangle, and it touches at these 3 points. You have the rectangle, and it touches at all 4 points inside the rectangle. Let's recall a definition from the past lesson. Recall that a tangent segment that intersects with the radius of a circle at a point forms a right angle. So anytime you have a radius that intersects a tangent line at a point, that's going to form a right angle. Tangent segments to a circle from the external point are congruent. That means 2 tangent lines that connect at a common point. From this point on the circle to the vertex, they have to be the same length. So if this has a length of, let's say, 5, this has a length of 5. All right, let's apply those theorems to solve a problem. Given a circumscribed isosceles triangle, find the radius of the circle. We know it's isosceles because these 2 sides are the same. You have a length of 12, and the base is a length of 8. Now, if you look at this, you have 4 tangent lines that are connected by a common point. So we can use that previous theorem. But what I'm going to do is I'm going to construct a perpendicular bisector, which says it's going to split this up to 4 and 4. And if I use that previous theorem, if this has a length of 4 from this point to this point, then this has a length of 4. And this has to be 4. And if you subtract 4 from 12, from the length from here to here has to be 8. So, what I can use is similar triangles in order to solve for the radius. So, remember we have 8 and 8. We don't know what the length is here, but this will be the diameter. If you can figure out what x is, we're just going to divide that by 2 and get the radius. We do know that the base of the original triangle is 8 and the side lengths are 12. So you have to start with the scale factor. So I can go from small to large. Let's say 8 is to 12 because I'm putting the corresponding sides together. If I reduce this, I wind up with, let's see, 4 divides into both of these. So I wind up with 2 to 3 is my scale factor. And we're going to use this to solve for x. So the setup will be 2 to 3. Remember, I'm going from small to large. So I have to go from small to large in my next proportion. So I have x is to 8. And what you're going to do is solve that proportion. So we had 2 to 3 is equal x to 8. So you cross multiply. So you're going to get 16 is to 3x. And you divide 3 to both sides. So you're going to get roughly about 5.3. I believe this repeats. And if you divide 5.3 by 2, we divide by 2 because we want the radius, that's the diameter. Then we get x is, it's going to be approximately 2.6. This concludes the lesson for circumscribed polygons.